In this video, we are going to discuss the intersection of solids, in which a horizontal square prism penetrates through a vertical square prism. Let us see the problem. A square prism 30 mm base side and 70 mm axis length is completely penetrated by another square prism of 25 mm sides and 70 mm long, horizontally. Both the axes intersect and bisect each other. All the rectangular faces of the vertical prism are equally inclined to VP. And two rectangular faces of penetrating prism are 30 degrees inclined to HP. Draw projections showing the curves of intersections. In this, both the prisms are square prisms. A square prism has four rectangular faces and two bases. The rectangular faces, or vertical faces of the vertical prism, are equally inclined to VP. This inclination of rectangular faces can be seen in the plan and is 45 degrees. Two rectangular faces of horizontal prism are 30 degrees inclined to HP, so, the other two rectangular faces are 60 degrees inclined to HP. This inclination of rectangular faces of horizontal prism can be seen in the side view. It can be noted that the rectangular faces are inclined to VP also. A rectangular plane 30 degrees inclined to HP can be seen as 60 degrees to VP. A plane 60 degrees inclined to HP can be seen as 30 degrees inclined to VP. Base corners of horizontal prism are named as A, B, C, and D. Base corners of vertical prism are named as 1, 2, 3, and 4. Intersection points, on the longer edges of horizontal prism on the left-hand side, are named as PA, PB, PC and PD. Intersection points, on the longer edges of horizontal prism on the right-hand side, are named as QA, QB, QC and QD. Intersection points, on the longer edges of vertical prism on the top part, are named as R1 and R3. Only longer edges 1 and 3 have intersection points. Similarly, intersection points, on the longer edges of vertical prism on the bottom part, are named as S1 and S3. We will start drawing the plan first. Because the base of the vertical prism can be seen in the plan, with all the sides equally inclined, that is 45 degrees inclined to the XY line. After drawing the XY line, draw a square below the XY line, with its sides 45 degrees inclined to the XY line, and each side is 30 mm. Name the corners as 1, 2, 3 and 4. Now, project all these corners above the XY line. Maintain the height of the prism in the elevation as 70 mm. The longer edges of the elevation are 1-, 2-, 3-, and 4-. In fact, the edge 4- will be invisible, but here it overlaps with the edge 2-. To draw the side view, draw a 45 degrees miter line from the XY line. Project the base corners of the plan to this miter line. Then project these points above the XY line. Maintain the height same as that of elevation. Longer edges in the side view are 1-, 2-, 3-, and 4-. In the side view also, the invisible longer edge 3-. Overlaps with the visible longer edge 1-. By this, three views of a square prism, standing vertically with its rectangular faces equally inclined to VP, are drawn. Now, for drawing the penetrating prism. Its base shape is seen in the side view, so that a square of 25 mm is to be drawn in the side view. At the same time, its two rectangular faces are inclined 30 degrees to HP. And, the axis of two prisms bisects each other. So, the axis of vertical prism, in the side view to be located first. Here in this case, the axis and longer edge are also overlapping. So the longer edge, 1 double dash, can be treated as the axis. Take the midpoint of it, and draw a 30 degrees line, and a 60 degrees line through this point. The side of the square is 25 millimeters. So, mark half of this, that is 12.5 millimeters, on both the sides of these lines. Draw parallel lines through these points. Now complete the square of the side view. Name the corners as A double dash, B double dash, C double dash and D double dash. In this side view almost all edges are visible. Except the portion of longer edge 1 double dash, inside the square. Through the miter line, project all these points to the plan. Maintain the length in the elevation and plan as 70 millimeters. The longer edges of horizontal prism in the plan are A, B, C, and D. Longer edge B is fully invisible. The portions of other edges passing through the square are invisible. Remaining parts are visible. Project all the corners of square in the side view, horizontally, to the elevation. Let the horizontal longer edges, A dash B dash, C dash and D dash. Mark the intersection points of horizontal longer edges, in the plan. PA, PB, PC, and PD, at the left-hand side. Longer edge B, in the plan must be fully invisible. Project these points to the elevation. Find out the corresponding points in the elevation. PA dash, PB dash, PC dash, and PD dash. Mark the intersection points of vertical longer edges in the side view. R1 double dash, and R3 double dash, at the top. S1 double dash, and S3 double dash, at the bottom. Project these points to the elevation, to find out the corresponding points. Mark the intersection points of horizontal longer edges, in the plan, at the right-hand side also. QA, QB, QC, and QD, at the right-hand side. Project these points to the elevation. Find out the corresponding points in the elevation. QD dash, QA dash, QC dash, and QB dash. For the horizontal prism, longer edge B dash, between 1 dash line and 3 dash line, is invisible. Longer edge C dash, is invisible between points, PC dash and QC dash. Longer edge D dash, is invisible between points, PD dash and QD dash. A dash is fully invisible. Vertical longer edge 1 dash, top portion is visible, bottom portion up to S1 dash is visible. Longer edge 3 dash, top portion and bottom portion up to S3 dash are visible. 2 dash is fully visible. Line of intersection, PD dash to PC dash. PC- to S1- are visible. Similarly, QD- to QC- and QC- to S3- are visible. PD- R1-, R1-, PA-, PA-, PB-, PB-, S1- are invisible. Corresponding lines on the right-hand side also are invisible.